Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to today's edition of the VOC Matric Revision Program with myself, Kanita Kamar, and my guest today is Muntasir Kadri. He is from Intune Tutoring, and today we cover mathematics in the session. And the topic is paper 1, question 2, and that's on sequences and series. I now hand over to Muntasir to proceed.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh, everybody. So, as per introduction, we will be covering sequences and series of math paper 1. We'll be looking at question 2, and question 3 also covers a little bit of sequences and series as well. And we'll be looking at things like arithmetic sequences and geometric sequences and how to solve them. Okay, so let's
Okay.
jump.
Okay. I think you need to just share the slides because that's
Is it
not being displayed.
is it not being displayed? I pressed share.
No.
Let me go back here again. Let me do this again. It says it's sharing. Okay, let me
Okay, let me
stop
add it to the
screen.
screen.
Let me
Should
just do
be.
this. I'm gonna share again. Share screen. Okay, there we go.
Okay,
There we
Bismillah.
go. Okay, there we go. Okay, perfect. Okay, lovely. So let us continue. So we'll be looking at question 2 first. Let us quickly jump into it. Let me just close this over here. There we go. Okay, so they say, given the arithmetic sequence -7, -3, 1, and 5, determine Tn. Okay, so now, of course, the first thing we need to do is we just go to our formula sheet and we see what we're looking for. So we know it's an arithmetic sequence, so there will be a specific equation that we need. Now let us go down. We scroll down to our formula sheet, which is over here. And if we look, so we have two equations for finding the term, right? Because t represents the term, where n is the nth term. Now, for any arithmetic sequence or series, you won't ever have anything to the power of some value. And for any geometric sequence, you will have a term where you have it to the power of some value over here. So, of course, this is the one we're going to be looking at to assist us in solving what the formula is. All right, so we'll just grab it here and we'll just add it to a new page. Just do that. All right, we go back here. Now, if we look at this problem, let me scroll all the way back up. Over here, this is what we're looking at. So we'll just copy this, add it to a new page as well. Oh, not a new page. Show desktop. Let me go back here. Give me a second. There we go. Okay. We'll add it to current page. There we go. Much better. All right. So now we have the information that we need to solve this. All right, let's go ahead. So first thing you need to do is you need to be able to identify what each of these terms mean. So A is actually the first term in the sequence. Okay. And that would essentially be term T1. Right? That's where n equals 1. D is the difference amongst the terms. And n is any value. So let's say you want to find the third term in the sequence. You'll let n equal 3, and it place 3 over here as well. So let's go ahead and we try to determine Tn. So now, the easiest thing to identify is that A is actually -7. So we have that. A is equal to -7. That is the first term in the sequence. And now we need to figure out what the difference is in the sequence. So we can just do this, just to assist us, and we can work it out. So the difference between the second and the third term, remember, it's always a difference between second and third. And I always like to do this. I write on top T1, T2, T3, T4. Now let's go second. And so we go to find the difference. We'll just go that the difference is equal to T2 minus t1. And we can write it in. So we got negative 3 minus negative 7. And we'll get negative 3 plus 7. And we find that our difference is 4. Now, is this true? Let us check that it's consistent. Let's check term 3 and term 4. Right? So term 3 and term 4 is going to be difference is equal to term 3 minus term 4. And that's going to be 1 minus minus 3. And that also gives us an answer of 4. So it's consistent. So we know we got 4, and 5 minus 1 is also 4, right? So we got 4, 4, 4. It's a consistent difference, a consistent first difference as well. And that's what makes something an arithmetic sequence, if you have a consistent first difference. If you end up having a consistent second difference, however, that's known as a quadratic sequence. Okay. Now we can go ahead and determine Tn, right? And we have the formula Tn equals A plus n minus 1d. And we can just go here. A is equal to negative 7 plus n minus 1. And the difference is 4. We go ahead and solve it. Negative 7 plus 4n minus 4. And our answer is going to be 4n minus 11. And that's how you find that. And let's just check if we are correct. Let's check the memo. And if you go here, 4n minus 11. Easy enough. Okay. Now, the second question, is 2.1.2. Calculate S30. Sometimes this throws students off. It does confuse them a little bit at times. But S just means the sum of. And 30 means the sum of 30 terms. Right? That's all it's telling us. So if we go to our formula sheet once again, now we need to find the sum for an arithmetic sequence. So we just scroll down to the formula sheet, and we can easily see that this is going to be the formula we need to use. Look how similar it is to this arithmetic sequence, right? So it's quite close. We've got a plus n minus 1 times d, and here the only thing extra is the 2 next to the a. So if you identify this common theme, you know that this is going to be the sum for this sequence over here. And we can see this also with a geometric sequence. Look how similar ar to the power of n minus 1 is with a bracket r n minus 1. So it's not the same thing, but it's quite similar, right? And that's why these two go together. Now, let us go ahead and try to solve this problem. Scroll up. Okay, hold on, let me just first copy this. We'll grab this over here, grab the formula, add it to a new page, and let me grab the question as well, which is over here. There we go. Calculate S30. Okay, so let's try it out. So they want us to calculate S30, where n is equal to 30. That's basically what S30 is. Right, so we can go ahead and we can go S30 is equal to 30 over 2 times by 2. I'll just use a square bracket for now. Times by 2 bracket. And what was the first term in the sequence? Well, it was negative 7. And that's what a is. So we put in negative 7 over here, where a is. Plus 30 minus 1. And we remember our difference was 4. Okay. Now we can go ahead and solve this problem. So now we're going to get 30 over 2 is 15. 2 times negative 7 is negative 14. Plus 29 times 4. What does this give us? So we get 15 times negative 14. 29 times 4. 9, 18, 27, 36, and 80. So that is 116. Equals 15 times 102. And we can just do this quickly. So that's 100 times. That's okay. So 15 times 102. 1530 is supposed to be our answer. Let's hope my mental arithmetic was correct. Let's just double check. 1530 is the answer. There we go. Easy peasy. Not too hard at all. Quite simple, right? Now, the next question, 2.2. Find values of x and y so that negative half x, y, 27 over 16 are in a geometric sequence. So we need to find the values of x and y, and we know that we are busy with a geometric sequence. Okay. So first thing we need to do, let's identify the equations for geometric sequence. We'll scroll down. Right, we'll look at the formula sheet, and these are the equations for geometric sequence. So we are trying to find the terms, the second and the third term, right? And we don't need to worry with the sum of a geometric sequence because that's not what they're requesting of us. So we just grab this, add it to a new page. Right, we know we're working with that. We go back here, scroll up. And give me a second. Here we go. All right. So now here's the question. And we'll just grab this out and add it to current page. There we go. So let's give it a go. So our first term, we know that a is equal to a negative a half. This R value is a ratio, right? And that R value is found by taking the second term and putting it over the first term. Okay? And the same can be said for this. Our R value is also going to be, we can say our third term over our second term. And we can also say our R value will be to our fourth term over our third term. It should all be constant. The ratio should remain constant no matter what. Now, we have our R value. Find the value of x so that are in a geo. So, and we have four terms. We know that n is equal to 4. Right? So we can go ahead and attempt to solve these. So let's see what happens. We don't have R, but we can figure R out. So I do know that my first term, T1, is equal to a negative a half. So let's see what we have. We have a term value. We have the n value. Our R is unknown, right? So it's pretty much a question mark right now. So we can see we have an unknown. So if we find R, that should assist us in solving for x and y. Let's see if that is the case. So I'll just go here. I'll say T1 is equal to AR. Well, we can't use 1 because then if we're going to use 1, we're going to get 1 minus 1. I'll just show you now. If I use 1, n is 1 minus 1. R to the power of 0 is just going to be 1. So we can't actually use this version to solve us. So let's go straight ahead and use the fourth term instead. T4 is equal to 27 over 16. So here we can say T4 is equal to A, which is a negative a half, right? That's times by R, where n is 4 minus 1. T4 is 27 over 16. This is going to be equal to a negative a half with R to the power of 3. Okay, now we know we want R as the subject of the formula, so let's get rid of this negative half, and we can divide it by this 27 over 16 here. And we should end up with 27 times 2, 54. We should end up with 54, negative 54 over 16 is equal to R to the power of 3. Now, can we simplify this further? Well, of course we can. We can go divide by 2. If we divide by 4, let's check. 54 divided by 4. Oops. Oh, so we can't do that. 54 divided by 2 gives me 27. Right? So I can use 2. So if I just show you over here, so I'll just simplify it. So I'll get negative 27 over 8. Give me a second. There we go. Negative 27 over 8 is equal to r to the power of 3. Now, this is lucky, right? So, as you know, if this had to be to the power of 2 equaling a negative number, we know that isn't possible, but we can have a cubic function equal to a negative value. So, our answer here essentially is we're just going to cube root this to find our ratio, and we're going to cube root this as well. And then what's going to happen? The cube root of, let's say this negative is on top here, negative 27, the cube root is just going to be 3, right? And the cube root of 8 is 2. And this is equal to r. And now we have found our ratio. R is equal to negative 3 over 2. So we can use this to assist us in solving these. Remember, the ratio is the second term over the first term, third term over the second term, fourth term over the third term. So this is going to be very useful for us. Now, I'll just write this on the side here. And I'll clear this board off. Negative 3 over 2. Right? We'll clear this away. And now we can essentially solve for x and y. Okay, we'll clear that off as well. So let's use the first term over the second term. And here we can see r, which is negative 3 over 2, is equal to term 2. So I'll just write it. This is term 1, term 2, term 3, term 4, which is term 2 is x, and t1 is a negative a half. Okay. Now, what we can do from here is we can just multiply by a negative a half, right, to get rid of it, because we want x to be by itself, right? So essentially, this is what we're doing. I'm multiplying this by a negative a half, and I will multiply this side by a negative half. Okay, what essentially happens here is, well, the halves just cancel. X will be by itself, and now we have to multiply this out. Remember, we have to multiply by negative a half by both sides. Otherwise, we're going to end up changing the value of the equation, which is not what we want. We want the value to remain the same. So, if we multiply a negative a half times negative 3 over 2, we are going to get 3 over 4 is equal to x. And then is equal to x. And there we go. We found x. Excellent stuff. Now let's go ahead and find y. And we do the same thing. We can just say term 3 over term 2, or we can go term 4 over term 3. Either one will be fine because term 3 is included. But let's use this one rather, because here term 3 is a numerator, so it makes it a lot easier for us to solve. Okay, so I'm going to say, okay, for this one, so let me just show you. So this was for this over here. We'll just circle it so you know. And then this one, to find y, we're going to say negative a half, negative 3 over 2 is equal to term 3, which is y, over term 2, and we found that to be 3 over 4. Now, once again, we do the exact same thing we did over here. We want to get rid of that 3 over 4, so we multiply by 3 over 4, and here, just clear this arrow off. We also multiply this by 3 over 4. Okay. Now let's see what happens. So the 3 over 4s cancel, easy as that. And 3 over 4 times negative 3 over 4 is basically negative 9 over 8 is equal to y. And those should be our two values, 3 over 4 and negative 9 over 8. Let's see if we are correct. Let's check the memo. Here we go. X equals 3 over 4. Therefore, y equals negative 9 over 8. Very, very simple. Not too hard at all. Now, just have to be careful. That's where understanding how to work with the terms and understanding the definitions of each specific point within an equation, what it means. Right? That'll assist you a lot, especially if you have a proper understanding of the actual general formula. So now the next question. And this often throws students off when they see summation notation. And they tell us here in 2.3, given that the sum of we're going to k equals 1, we're starting with k equals 1, and we can go to n terms. So it just, we don't know what the value of n is. We'll find it out, right? They tell us that 3 times 2 to the power of k minus n is equal to 38. So they're telling us for a certain number of terms, starting with k equals 1, that the sum of all those terms will give us 381. That's what they are telling us. And we can see that this is geometric. I mean, it's k to the power of -1, isn't it? Right? So let's go ahead and try to solve it. So once again, we just go to our formula sheet. We know this is geometric. Scroll down here. All right. And once again, this also depends on our ratio. If our ratio is equal to cannot equal 1, if our ratio is greater than 1, then we're going to be using this equation. Right? But we do know we have an n value, so it is finite. It is a finite geometric sequence, and this is infinite. So we don't really have to worry with the ratio as of yet, because they tell us it's a finite sequence. Okay, so let us go back here. Just give me a second. Which question was this? 2.3, 2.4, 2.3. Okay, yeah, was it? Yeah, correct. Let us scroll up. 2.3. There we go. There we go. Okay, so let's see what we can do here for 4 marks. Let us add this to a new page. Here we go. Now, if we must find the first term in the sequence, it's very simple. We just substitute k equals 1 into here. Okay? So we can go ahead and do that. So the first term in the sequence is going to equal 3 times 2, k is 1 minus 1. That's going to give us an answer of 3. So we know that the first term is equal to 3. Okay. We can go ahead and let's see what the second term is. This is 3 times 2. Go 2 minus 1. So that's going to be 1, and our answer is going to be 6. And this is telling me that we have a ratio of 2, and here's odd. This is odd. That's the actual odd value. This is A. That's our A value, right? And k minus 1. Okay, so this shouldn't be too hard for us to solve. So now we can go ahead and let's give it a try, right? So let's see. So we got that. So let's just go back to this equation. Did I copy it? Should the equation be here? No, here's the equation. Give me just 2 seconds. I'll get it for you now. Here we go. This is the equation we need to use. So let's just show desktop. Let's copy it over onto the current page. Add to current page. All right. So now we have our information. So we have Sn, right? And we know Sn is some value, and it's equal to 381. That's what they tell us. So when you see summation notation, know that this is also the same equation that you can use for this, right? This just helps you derive certain values, A and R, which are very important, right? N is an unknown. That's what we're trying to find. So we can go ahead and let's say that equals 381, and that is equal to A, which is the first value. So we just say 3 times by R, which is 2, to the power of N minus 1 over 2 minus 1. So here we'll get 381 is equal to 3, and this is going to be 1, so it just remains 3 times 2 to the n minus 1. Now let us divide by 3. Let's see, 381 divided by 3. Just check on the calculator. That's going to be 127. 2n minus 1. Take the 1 over, we'll get 128 is equal to 2 to the power of n. Now, we need to get 128 into its exponential form with the base of 2. Okay, this is the base of 2, that's the exponent. So we want the base of 2 and some exponent. And let's see, and all you do here is you just go, see how many times 128 can divide by 2 over and over again. So 128 divided by 2 is 64, divided by 2 again is 32, divided by 2 again is 16, divided by 2 again is 8, and divided by 2 is 4, divided by 2 is 2, divided by 2. So 2 to the power of 7 should be the value, that is correct. So now we have 2 to the power of 7 is equal to 2 to the n. And then there we can just say, therefore, you ignore the bases, n is equal to 7. And that will be your final answer. Let's check if we are right. See here, and there we go. N is equal to 7. As simple as that. Now, let us look at the next problem. We'll go up here. All right, here we go. 2.4. The first term of a geometric series is 3y, and the second is y squared plus y, where y cannot equal 0. So they've given us a restriction. Determine in terms of y the common ratio in its simplest form. So we know the ratio is the first term divided by the second term, and here they give us the first and the second term. So let's just copy this, add it to a new page, and let's take a look. Okay, so term 1 is equal to 3y. And we know that term 2 is equal to y squared plus y. To solve for a ratio, we can say the second term over the first term. So this is going to be y squared plus y over 3y. Y is a common factor, so we'll just go y bracket y plus 1 over 3y. We can see that the y's will cancel, and our ratio comes down to y plus 1 over 3. Are we correct? Let's check the memo. And there we go, y plus 1 over 3. Right? Now, let's go back here. Okay. Find the values of y such that the series is convergent. Now, this is very important. When a series is convergent, that means we have a finite series. If the series is divergent, we have an infinite series. So what are the restrictions? Well, it's actually in your formula sheet. If we scroll down, actually, we don't even have to. I did copy the formula. Oh, no, I didn't copy both. So if we scroll down and we look at the formulas for a geometric series, there's 2. Right? There's 2 for the sum of a geometric series. And if we look here, if it is this is convergent. Convergent is infinite. Sorry, divergent is going to be finite. So if we look here, S to infinity, the restriction is between 1 and negative 1. And that's the restriction we're left with for our ratio. And this should assist us in solving this problem. So if we go back here, scroll up. Oh, I can just go here. Sorry, my apologies. Go back here. Right? Find the values of y so that the series is convergent. So we can just go here. We know that odd is going to be less than 1, but greater than negative 1. That's what they stated. Let's see. Double check that. Make sure it's correct. There we go. Less than 1 and greater than negative 1. Okay. We go back here. And now we can find the values of y for convergent series. Right, so this is for convergent series. And we can just go, well, then we got we'll essentially have y plus 1 over 3 is less than 1 but greater than -1. And you've seen this before. This is basically inequalities, right? Don't forget to use the number line to double check that your answers are correct, and we'll just jump into it now. So let's take a look. So this is going to be -3 is greater than y plus 1 and less than 3. We move the 1 over on both sides. This is going to be -4 for y and 2 on the side. And this is essentially going to be your answer. Y is between 2 and -4. Right? These are the values for where y is convergent. So let's double check the memo. Are we correct? There we go. Y is between -4 and 2. So 2.4.3. Let's take a look. Scroll up. There we go. Question 2. Excellent. Okay. Given that the series is convergent and y is an element of natural numbers, calculate the sum to infinity. Okay. So they want us to calculate the sum to infinity. So therefore, we have to use this equation down here. You scroll down. So it's convergent. So now we have to use this equation here. The sum to infinity is equal to a over 1 minus r. As easy as that. So we go over here. Okay. And for 2.4.3, clear this off. Right. Given that the series conversion, calculate the sum to infinity. So the sum to infinity is equal to a over 1 minus r. Right? They tell us y cannot equal 0. And, oh, I actually should not have deleted all of it. Give me a second. There we go. I got it all back. Okay, lovely. So we have to use this information. So I'll just write it 2.4.3. Okay, we need to use this information. So we got the sum to infinity is equal to a over 1 minus r. Right? We know that a is equal to 3y over 1 minus, and our ratio is y plus 1 over 3. Okay. Were there any, y is an element of natural numbers. Okay. So we have our restriction where y can exist. Y is either less than 2 or greater than or equal to -4. So we can select any value between there and it will be fine to use. So we can say, okay, let's let y equal 1. Right? So we can go in here and we can just substitute 1. So we'll get 3 over 1 minus 2 over 3. This is going to equal 3 over 3 minus 2 over 3. That's going to be 3 over 1 over 3. And that is essentially going to give us an answer of 9 if y was the value of 1. But now, are we correct for using that? And here we go. Our answer is 9. So it's easy as that. You find the restriction and you select any value within that restriction to substitute into here to find the sum to infinity. Not that hard at all. Okay, so let's quickly go back here. And there is another question, question 3, which also involves sequences and series. I believe this one involves a quadratic sequence. Let me just double check. Okay, so here we go. They say, given a sequence with a constant second difference, so they tell us it has a constant second difference, so therefore we know it's a quadratic sequence. Okay. K, comma 18, comma 28, comma 40, M, 78, 8, and N. That's the sequence they give us. And they say determine the values of K, M, and N. Okay. Now, let's take a look at this. Let's see if we can identify the second difference. And we do know this is a quadratic sequence. So the first thing we're going to do is let's copy this, add it to a new page. And what you need to know for this is, if we go over here, let me just zoom in, something very important for quadratic sequence, which students often overlook. I'll zoom in some more so you can see this. Okay. So if, give me a second, I went to 500%. Just zoom out. Okay. Scroll down. Here we go. Right. If we look at this, it shows that Tn equals an squared plus bn plus c, which is basically the same formula as a quadratic formula, right? And if you look over here, I want to zoom in for you. It's a bit too small. Okay. There we go. All right. And here we have n equals 1, n equals 2, n equals 3, n equals 4. Important thing to notice are these general formulas that they're showing here. For the first term, you have the form a plus b plus c. For the first difference, it's 3a plus b. And for the second difference, it's 2a. This is very important. You need to know this in order to solve quadratic sequences. Now, okay, I can see the time's a little bit limited. So let us just go to the memo for this one quickly. And if we look at what they did here, okay, they set up some table for question 3. And if you look at question 3, it states K, 18, 28, 40, M, so on and so on. And here they did that. They got K, 18, 28, 40, M, 70, 88, N. They set up the sequence on top. In the second row, what they did was they found the differences between each term. This is the difference between the second and first term, 18 minus K. This is the difference between the third and second term, it's 10, so on and so on. And then they laid this out. Then they got to the second difference, and we found that the second difference should be 2 consistently throughout, because they tell us the second difference is constant. So here we got negative 8 plus k, here we got 2, m minus 52, so on and so on. And very easily, we can then solve using some simple algebraic manipulation, knowing that the second difference is supposed to be 2, and state that minus 8 plus k equals 2. We move the 8 over and we find that k equals 10. Here they said m minus 52 equals 2. Therefore, m equals 54. We just move that over. And for n, we do the exact same thing. Set the second difference to equal to 2. And therefore, n will equal 108. And it's really, really as easy as that. Okay. Let me see if there was anything else. Yeah, so I'll just show you manually. Let me just do this, add to a new page. I'll just show you how they did this manually. So maybe it won't be as confusing as seeing that table. And we'll just do this quickly. All right, so they tell us we have a constant second difference. And we can see here our second difference is supposed to be 28 minus 18. Actually, I think they made a mistake in the memo now that I'm looking at this question. Just give me a second. Oh, sorry, second difference. That was first difference. Yes, no, they did not make a mistake. Okay, go back here. Now, let's take a quick look. So we'll write out our terms. K, 18, 28, 40, M, 70, 88, and N. Here in this line is our first difference, which is 18 minus K. 28 minus 18 is 10. 40 minus 28 is 12. This is M minus 40. This is 70 minus M. This is 18. This is N minus 88. Second difference, we'll write that over here. (10 minus 18 minus K), so that's minus 8 plus K. This is 2. m minus 40 minus 12 is going to m minus 52. 70 minus m minus 40. That's going to end up being plus 40. So we're going to end up with 110. So we should end up with 2m plus 110. And here we should get 18 minus 70. So we're going to get m. 18 minus 70 is about 40, 50, 60, 52. All right, so minus 52. And we do the same thing over here, n minus 88 minus 18. And that's basically what they did. And then they went ahead and they found, oh, 2 is the common difference. And then they stated that each second difference is equal to 2. And then they solve for k, m, and n in that order. Okay. So we'll end there for today. We ran out of time, unfortunately. Any information or any memos or any questions that you're looking for will be on the Intune website. And there will be a link provided. Just follow that link, and all past questions, all answers that you might be interested or you need to look at will be available there. I hope you enjoy the rest of the day. That ends our session. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum salam wa rahmatullahi wa barakatuh, and shukran very much to you, Muntasir, for today's session. A reminder that the session is recorded, so if you've missed out or perhaps there are matriculants who weren't able to join us live, this is recorded and will remain on Facebook and YouTube. That's the Voice of the Cape Facebook and YouTube pages. From myself, Kanita Kamar, and my guest today, Muntasir Kadri, we bid you farewell. Assalamu alaikum wa rahmatullahi wa barakatuh.